In this video, we're going to talk about related rates. And let's say you have a volume of a sphere. Volume of a sphere is 4/3 times pi r cubed. If the radius is increasing, that means the volume is increasing. If the radius is decreasing, if the radius gets smaller, then the volume of a sphere is getting smaller as well. If you want to find the rate of change of the volume respect to time, so that's going to be dv over dt. We're taking the derivative respect to time. So derivative of v will be dv over dt. And the derivative of that will be 4 pi r squared. And you need to take the derivative of r. So it's going to be dr over dt. Remember, in related rate problems, we're taking the derivative of variables respect to time. So it is very similar to implicit differentiation. It's just now we're taking the derivative respect to time. So what does dv over dt represent? It represents the rate of change of volume respect to time. If the volume is increasing, then dv over dt will be positive. If volume is decreasing, dv over dt is negative. What about dr over dt? That represents the rate of change of r respect to time. If dr over dt is positive, that means the radius is increasing. If dr over dt is negative, radius is decreasing. Now, what about volume of a cone? You know that the volume of a cone is pi over 3 times r squared times h. So how do we find the rate of change of the volume with respect to time? Well, that's going to be dv over dt. And in order to find the derivative of that, notice that pi over 3 is a constant. And we got to find the derivative of this respect to time. So we have to use a product rule. So it's going to be r squared times the derivative of h respect to time. So that's dh over dt plus h times the derivative of r squared respect to time. So it's 2r dr dt. So you end up getting pi over 3 times r squared dh over dt plus 2hr dr over dt. So that is going to be the dv over dt, which represents the rate of change of cone, volume of a cone with respect to time, and dh over dt represents the rate of change of height with respect to time, and dr over dt represents the rate of change of radius with respect to time. Let's say you have d equals square root of x squared plus y squared. By the way, this is the distance formula from an origin to a point. How would you find the rate of change of d with respect to time? So in order to find the derivative, let's rewrite this as quantity x squared plus y squared to the 1/2. Now let's find the derivative of d with respect to time. So dd over dt is equal to, what is the derivative of that? You have to use a chain rule. So 1/2 times the quantity x squared plus y squared to the negative 1/2 times the derivative of inside. So derivative of x squared with respect to time is 2x dx over dt plus 2y dy over dt. Let's take a look at this example. Mr. Kim hits a golf ball into a pond. of still water, causing a circular ripple. If the radius of the circle increases at the constant rate of 0.7 meters per second, so think about it. This represents dr over dt, change of radius with respect to time. That is going to be 0.7. Since the dr dt is positive, you could tell that the area is increasing. It says how fast is the area of the circle increasing? We need to find dA over dt, rate of change of area of a circle with respect to time when the radius of the ripple is 3 meters. So in order to solve for dA over dt, the area of a circle is pi r squared. And what is the derivative with respect to time? dA over dt is going to be 2 pi r dr over dt. In order to find out dA over dt, we have to plug in the given information. Is 2 pi times radius will be 3, and the rate of change of radius with respect to time is 0.7. So you end up getting 13.1948, and that will be meter squared per second because it is the change of area with respect to time. So when radius is 3, the area of a circle is increasing at 13.1948 meters squared per second. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the lift-off point. So here's a lift-off point, and here's a rangefinder, which is 500 feet away from the lift-off point. At the moment, the rangefinder's elevation angle is pi over 4. That means this data will be pi over 4. The angle is increasing at the rate of 0.14 radians per minute. So that means d theta over dt is 0.14. Since d theta over dt is positive, you know that the angle is increasing. Now, how fast is the balloon rising at that moment? So we got to find dH over dt when the theta is pi over 4. Now, let's look at the relationship between theta, h, and 500. Using trig, you know that the tangent theta will be opposite over adjacent. So we could say tangent theta is h over 500. Now notice, the variable that is going to change with respect to time is theta and h. 500 is constant. It will always be 500. Now we got to find the derivative of this respect to time. So what's the derivative of tangent theta? Well, it's secant squared theta, and the derivative of theta is going to be d theta over dt. What about h over 500? It's going to be 1 over 500 times the derivative of h, which is dh over dt. Now our goal is to find dh over dt, so let's multiply 500. You get 500 secant theta squared d theta over dt equals dH over dt. Now let's plug in our given information. So it's going to be 500 times secant of pi over 4. That's squared. What is d theta over dt? That's 0.14. That is going to be dH over dt. And what is secant of pi over 4? Well, that is the same thing as 1 over cosine of pi over 4. And cosine of pi over 4 is radical 2 over 2. So 1 over radical 2 over 2 is going to be 2 over radical 2. So this is going to be 500 times 2 over radical 2 quantity squared times 0.14. And it's going to be 140. So dH over dt is going to be 140 feet per minute. So how fast is the balloon rising at that moment? At the moment when theta is pi over 4, the balloon is rising at 140 feet per minute. And since dH over dt is positive, it means the h was increasing. Let's say the balloon was coming down. Then dH over dt will be negative.